Okay, let me get your attention and we'll get started. So we left off on Monday. We said when describing a relationship between two numeric variables, we want to describe the shape. Okay, and for the shape we said it could either be linear or nonlinear. We want to describe the direction. The direction can be positive, negative, or neither. And then lastly, we want to discuss the strength. And we left off, we didn't get to the strength. So here we will talk about the strength of a relationship. Okay, and so the strength of a relationship, we can either use the word strong. So let me just kind of list off. We can have strong, weak, or something in between, such as moderate. Okay, strong would indicate that there is little scatter around the trend line. Okay, but there's little scatter around the trend line, or another way to think of it is that if we have one variable we can make good predictions about the other. And then weak would be the opposite of that. This is lots of scatter. Around the trend line. And this would say, meaning that if we have only one variable, or if we have one variable, we can make predictions, but our predictions will not be very good. Okay? So if I were to draw little diagrams here, a strong relationship, you have your trend line. So this would be strong. Okay. And on the other hand, you might have a lot more scatter. So that overall there's still perhaps a positive trend, but the relationship is weaker. Okay. Or another way again, we can say, if you're given this x value and you had to make predictions, with the strong relationship, our predictions would be within this tight window here, okay, for that particular x. Okay, and over here, if you're given this particular x value, then your prediction window is much wider, right? So you have a lot more spread around. This is kind of where our predictions would be. And then we see more variability. In our predictions. Okay, so that covers the strength, and then anything in between. If the relationship continues to get weaker and weaker and weaker until there's really no definable relationship, then it can become to the point where there's no relationship. Okay, here there's still a positive trend or positive relationship. It's just a lot more dispersed. And so we have a numeric summary, okay? We have a statistic that quantifies the direction and strength. And I should say of a linear relationship. Okay, and this quantity is called the correlation coefficient. Okay, or a lot of times, or just plain old correlation. The symbol is R. Okay, as in relationship. Okay. And the correlation, let me just say this. The correlation is just the result of plugging some values into a formula, okay? So the correlation can be calculated for in any data set with two numeric variables. Okay. However, the interpretations and the utility of the correlation is the interpretation only makes sense if the relationship is linear. Okay, so you can still calculate correlation even if it's not linear. It's not going to have any meaning there. All right, so let me just give you some correlation facts or correlation interpretation. So correlation can be any value between -1 and 1 inclusive, okay? The sign of R, the sign of the correlation, is the direction of the relationship. So So the sign of R is the direction of the relationship, meaning if R is positive, the direction is positive. If R is negative, the direction is negative. Okay. If R is close to 0, the strength of the relationship is weak. And if R is close to 1, or I should say if R is far from 0, so meaning it is close to 1 or close to -1, the relationship is strong. So R quantifies, the correlation coefficient quantifies the direction and strength of the relationship. Okay? It does not tell us anything about the shape of the relationship. Okay? So it is important to note that R does not tell us that it does not tell us anything about the strength of relationship. I mean, tell us the, I apologize, the shape of a relationship, not the strength. It tells us the strength, it does not tell us the shape. Okay? So R will not tell you if it's linear or nonlinear. Okay? Even the only time it is linear, you can say R tells me it's linear, is if R is equal to 1 or R is equal to -1. Even when R is 0.99, it doesn't mean that it's linear. Okay? How can we tell if the shape is linear or not? We have to make a scatter plot. Okay? That's really the only way we can tell if the shape of a relationship is linear. Okay? So to decide the shape, we must look at a scatter plot. Okay, so let me just give you a few examples of values of R and maybe some associated scatter plot. Okay, and I'm just kind of making these up, but I think more or less I'll be kind of close. Okay, so if we have something like this, okay, so our points are in a perfect straight line. The R here is +1. Okay. If you have a little bit of scatter, something like this, R would be something like 0.98. Okay, and as the amount of scatter increases, R gets, lower and lower. Something like that. Okay. Until you get to some point where there's no relationship. Okay, and over here, I hope you guys can see these dots. R would be 0. Okay, so examples, I'm just going to make some things up here, is we could say you measure the weight of a person in pounds, and then you figure out their weight in kilograms. Meaning that if you know someone's weight in pounds, you can predict what their weight in kilograms would be exactly, okay? Because you just multiply it by a number, you have a direct formula. There's no... If two people weigh 120 pounds, okay, then their weight in kilograms will be exactly the same for both of those people. Okay. Over here, we have, you know, maybe something strongly correlated. We can say, you know, each dot is a country. Or each dot is a nation. And this could be life expectancy for males and life expectancy for females. And we would expect a very strong correlation, but maybe not exactly the same. So if two nations, if you looked at a nation and the life expectancy for males is, let's say, 74 years, okay? Let's say country A has life expectancy 74 for males, and the life expectancy for females may be 77, okay? If you look at another country where the life expectancy for males is 74, that other country might have something very similar. Maybe the life expectancy for females is 78, okay? We don't expect it to be exactly the same, but we expect it to be very, very close to the other value, okay? We would be surprised if one nation had life expectancy 74 for males and life expectancy for females, you know, 55 or something like that. That would be rather shocking if there's a huge discrepancy there, okay? As far as, you know, all countries where the life expectancy for males is 74, we would expect the life expectancy for females to be 76, 77, 78, okay? Because, you know, internationally, globally, there's a general trend that females live maybe about 3 years longer than males on average for a multitude of reasons, but that's kind of what we have, okay? And then, you know, as our predictive power decreases, you know, our drops, okay? You know, over here we have r equal to 0. This could be something like someone's SAT score. We'll say SAT verbal and shoe size, okay? We would not expect to see any kind of relationship between someone's verbal SAT score and shoe size. You'll have people who scored high with big feet, people who scored high with little feet, people who scored low with big feet, people who scored low with little feet, and everyone in between, okay? We would not expect to see any kind of relationship. What is this? What is the R for this relationship? It's supposed to be a perfectly flat line, okay? So perfectly flat line. What would you say R is? Should we make a question out of this? Just R is 0, okay? This is a flat line, okay? It's neither positive nor negative, okay? R here is 0. This expresses, is there a relationship between X and Y? This could be something like money in the bank. How much money do you have in the bank? Okay. And I don't know, number of kidneys you have, okay? Okay. Pretty much, you can have lots of money and you'll have 2 kidneys. You can have very little money and you'll have 2 kidneys. Okay. Now, I realize some people may not have 2 kidneys, but in a small sample, okay, in a small sample, this is what we might see. Okay. Okay. I don't know. I suppose somebody could have just sold their kidney and now, I don't know. Okay. But in general, okay, if you take a random sample, money in the bank has no relationship to a number of kidneys, all right? So this would be no relationship. So a flat line indicates no relationship. Even though it looks like a perfectly straight line with no scatter, if it's flat, there's no relationship. Okay? Okay, let's try a little something here. Okay, so we have so we said here R is 1. And here we have R is 0. Here, let me make a... Okay, right here I have R equal to what? -1. Okay, and then this will be your little clicker question here. We'll say R is equal to -1. B is R is between, we'll say R is close to -1, but not quite. So 0.92. Okay. R is negative, close to 0. Okay. And D will be something else. Okay, and so here, the line looks like this, okay? So it's, they're supposed to be in a straight line. Straight line, but slope is shallow. Okay, you can discuss with your neighbors what you guys think the answer should be. So the dots are in a straight line. Okay, in 3, 2, 1, get your clicks in. Click, click, click. Okay. All right, let's see. Ooh. Okay, so we are classroom divided. Okay. All right. The dots are in a straight line, perfect straight line. It's pointing down. But the slope is shallow. The answer is going to be A. It's -1. Oh, yeah. Okay. So let's just let's talk about this, right? What does R measure? Remember, so R tells us the direction and strength. Okay? And when we talk about strength, the idea was, is there lots of scatter or little scatter, right? How much scatter is there? Scatter around the line. So if we imagine a line being drawn here, oops. So if I draw, just kind of a thin line here, there's no scatter around the line, indicating that you have a very strong relationship. Okay? So one thing to note that's important is that slope does not tell us anything about r. Okay? Or r does not tell us anything about the slope, I'll say. Okay? R has nothing to do with slope. Okay? So if the line is shallow, even if the line is shallow, r here is still -1. Okay? Because r only has to do with the direction and the strength. Yes, we have a question.
If slope doesn't matter, then why is the flat line equal to 0?
Because it's slope and direction, right? I mean, not slope, strength and direction. Okay? So in both of these, the direction is negative. The direction is negative here. Okay? Direction is positive. Right here, the direction is neither positive nor negative. So yes, you have, like, if we had this line that was rotating or sweeping, like from up to down, it would be 1, 1, 1, 1, 1 until it gets flat, then it's 0, and then as soon as it starts pointing negative, then it becomes r is -1. Okay, it's not a nice smooth curve or anything like that. Yeah, another question.
So when it's vertical, is it also 0?
If it's vertical, it is also 0. Vertical will be 0, although vertical has its own problems, right? Because the idea here is, we're using one variable to make predictions about the other, okay? If you have a vertical line, then that means you've only observed one value of x, okay? It'd be kind of like, oh, how many kidneys do you have? And I want to try to predict how much money you have in the bank, okay? There's no relationship there, but we've only seen, we've only observed people with 2 kidneys, or I don't know, maybe another example, we're asking something and we only observe people with one particular value. That variable is not going to give us much insight, okay? So yeah. So r has nothing to do with slope. It's entirely direction and strength, okay? And so we have just a few key points regarding r. Okay. So as far as r goes, the order of the variables does not affect r. Okay, so the correlation between x and y is exactly equal to the correlation between y and x. Okay. Multiplying one of the variables by a constant or adding a constant to a variable also has no effect on r. Okay, so another, this can be thought of as changes in unit will not affect r. Okay, because changing units effectively is just multiplying or adding a constant. Even changes from Celsius to Fahrenheit or things like that. Okay, and that's also why the slope doesn't affect r. So here we had this. We said this thing was -1. Okay, and if you think about it, if I turn it like this, all we're doing is really just stretching the horizontal axis. Okay, we're just effectively multiplying the horizontal axis by a constant. Okay. Okay, so those do not affect R. R only makes sense for linear relationships between two numeric variables. Okay. And again, how do we tell if something is linear? We make a scatter plot, right? Okay, and then R can be greatly affected by outliers. So these are just some ideas here. Okay, so let me give you another question here. Okay, so you'll say, you gathered some data. You gathered some data, and you find that the correlation between x and y is equal to 0.95. Okay, so we would say true or false. True will be A, false will be B on your clickers. Okay, true or false. Okay. This means that the relationship between x and y is positive, linear, and strong. Okay. So you can go ahead and discuss. Okay, we'll say 10 more seconds to get your. I'm running out of battery here. Okay. So we'll say 10 more seconds to, or just get your clicks in here. Can you guys still hear me? My mic ran out of batteries. Okay. Let's see what happened to my cursor. Okay, we'll take a look. Okay, and the answer is false, indeed. Okay. Yeah, this is all right. And so the reason why it's false is this. Okay, this is not true. Okay. Okay. We can say it is positive, and strong. Well, we don't know, but we can't it certainly will not tell us if it's linear or not, okay? This is certainly, R cannot tell us if it is linear. Because if you had data that looks like this, okay? If you had data that looks like this, the correlation here will be something around 0.95, okay? The correlation for this data will be something around 0.95, okay? And this is clearly not linear, okay? Correlation can be calculated for any data set where you've got a numeric x and a numeric y. You just plug it into a formula and it will spit out a value. But it doesn't necessarily mean that the relationship is linear, okay? So this is a possibility. Okay? I mean, it's also possible that that you have a linear relationship and there's just a tiny bit of scatter, and so you get r is equal to 0.95. This is also possible. But just from looking at this, you find the correlation between x and y is equal to 0.95. That will not tell you if it's linear, okay? So we must make a scatter plot to decide if something is linear. There is something called Anscom's Quartet. And let me hop online to look this up here. Anscom's Quartet. Let's get this picture. All right. There it is. Copy image. All four of these all four have a correlation. All four data sets have the same mean here. Let me also just copy this. Okay. Like if you calculated, oops, where did this go? Did that not work? Okay. All four have these properties. That that the mean is 9, the standard deviation is the square root of 11, or the variance is 11, the mean of y is 7.5, and then the standard deviation of y. All of these have the same mean of x, all have the same mean of y, all have the same standard deviation of x, and all have the standard deviation of y, and all have the same correlation r equal to 0.816. Okay, so for all of these, r is equal to 0.816 for all data sets. Okay, but we can see that, you know, correlation really only makes sense for this diagram, okay? Okay. Over here, this is not linear. Okay. Over here, the correlation should probably be exactly 1, except you have a single outlier that's throwing everything off. Okay. So we would want to, we have one outlier that throws off an otherwise straight line. Okay. Okay, and so you definitely want to investigate the outlier. Perhaps it's a typo, okay? Perhaps whoever was typing in the numbers accidentally hit the wrong key, and that's why you have this thing, okay? We would want to investigate. Maybe it's a real thing, maybe it's a mistake, okay? We don't know. Okay, we should investigate the outlier. Okay, and then over here, this one, this is like the most egregious. This is pretty much all of your data comes from when x is equal to 8. Okay, well, we have a question before we go on. Yeah.
Oh, so does that mean the only exception to the rule that R can't tell us the shape is if R were 1 or -1?
Yeah, if r is 1 or if r is -1, then you can say it's a perfect straight line, okay? But other than that, r can, like, r is 0.99. If it's not perfectly 1, then they're not going to be in a perfect straight line, and you don't know if it's curved or straight or whatever, okay? We can always kind of manipulate, make an artificial data set with certain properties, okay? If r is 1, then it's going to be a straight line, yeah. Okay, and over here, pretty much all data points have x equal to 4. Or x equal to 8, okay? And then you have one x value out here at, 19 or something. And you're basically creating your trend line based on this one observation here, okay? So it's kind of like you ask somebody, how many fingers do you have? Every single person you ask, they have 10 fingers, okay? And then you say, well, okay, how much money do you have, right? And then, you ask a whole bunch of people, and then you just get this average amount of money, whatever, okay? Your annual income after you is $60,000 or whatever, 10 fingers, okay? And then you come across one person who has 11 fingers, okay? And this person with 11 fingers somehow is a millionaire, okay? And now you're going to say, oh, well, this shows it. The more fingers you have, the more money you're going to make, okay? That would be a ridiculous conclusion, okay? But that's basically what's going on here. All of our data has x equal to 8, and we get some kind of range here. And then we have just one person who has a different x value, and we're creating an entire trend line based on that one observation, okay? We have one observation with a different x. And that value is used to create the trend line. Okay, so that would be a terrible thing to do, but you'll be surprised how often something like this is committed, where you have very few data points in a certain region, and based on those very few data points, people are making conclusions or something. Okay. All right. On Friday, we'll go over how to determine the trend line, how that's determined. Okay. We'll see you guys.